4 ways mentioned in the material to test for convergence of a series. Now, instead of stressing myself to start it, let me ask you guys to tell me these 4 ways. So anyone to tell me one of the methods, because this might be one of the questions in exams. They just say which one is not a method to test for the convergence of a series. So please, anyone to tell me one method?
Comparison method.
Thanks a lot. We have the comparison method.
We have the ratio test. Ratio test method.
What do you say? Ratio test method. Thanks. Ratio test method. Okay, what else?
The Alambert ratio test method.
Alambert ratio test. The Alambert ratio test. And anyone else?
Cauchy's integral test.
Thanks a lot.
Or Cauchy.
It's Cauchy, yeah. Cauchy's integral test. Yeah, these are the 4 tests mentioned in the material and nothing more in the material. I've said this several times that there are so many tests to use. Now, we've actually used comparison method a lot, which we have the video if you want to check it out. We've used the Alambert ratio test a lot. The ratio test method, I'm not willing to use that. It's also not hard at all. But the Cauchy integral test is really hard, to be sincere with you. You will have to know how to integrate very well before you can use the Cauchy's integral method. Cauchy's integral method involving you having a series like this. This series where R is from 1 to infinity. For this particular series, let's say R factorial over R raised to power R minus 1. Well, if someone could use, now you're asked to test for the convergence of this series. If you are asked to test for the convergence of this series, basically, one can just apply the comparison method can be used if you could make it into the expanded form. The expanded form means having plus, plus, plus. As well, you can use the Alambert ratio test, right? But now, how can you use the Cauchy's integral test? Cauchy's integral test is telling you that you have to limit, in case you encounter it and they say which formula is this, it is the Cauchy's integral test. Limit b to infinity, where the thing is from 0 to b. Your r now change to x. It will now be x factorial over x raised to power x minus 1 dx. Now, to test for convergence of this thing, we need you to know how to integrate this function you're seeing here. So you can ask yourself, can you integrate x factorial upon x to the power of x minus 1 dx? If you could integrate it, that means you are welcome. I can teach you the Cauchy's integral method privately. But if not, just forget about using the method for now and concentrate on the Alambert ratio test and the comparison method. But in case you encounter it this way,
it's kind of blurry.
Sorry, it's b to infinity. In case you encounter something like this, just know that it is the Cauchy's integral test. It is the Cauchy's integral test. In case you encounter something like this, just know that it is the Cauchy's integral test. Now, so what we're going to have tonight, let's start with the alternating series. Alternating series. What do I mean by alternating series? Alternating series means a series that has its terms alternating between positive and negative. Alternating between positive and negative. See, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. Like that. What do I mean by that? That means the series can come this way. AR is equal to 1 over 2 minus 1 over 3 plus 1 over 4 minus 1 over 5 plus 1 over 6 minus 1 over 7 plus 1 over 8 to infinity, what do you observe? You observe that it is alternating between plus 1 over 2, minus, plus, minus, plus, minus, plus, minus. This is the type of series we call an alternating series. An alternating series has its terms alternating between positive and negative. The ones we've been dealing with so far, they are known as positive series. But this one is what? Alternating series. Now, if you encounter something like this anywhere, this is summation of AR, where R ranges from 1 to infinity. If it is equal to summation of the general formula for this series, like a summation of R factorial all over 3 raised to power R open bracket R plus 3. If from 1 to infinity, if this is the general formula for the ratio, then I can say very well that this is a positive ratio. There is no tendency, positive series. There is no tendency that this could ever be an alternating series. But what gives me the assurance that I encounter an alternating series whenever I encounter it? That means the series is going to be starting with minus 1 raised to power something. So whenever a series is having minus 1 raised to power, maybe R minus 1 all over 3 raised to power R, starting from 1 to infinity, just know that this is an alternating series. Why? Because it is starting from minus 1. Now let us expand the series that is ranging from 1 to infinity, minus 1 raised to power R minus 1 all over 3 raised to power R. Let us expand this now. Then you are going to confirm it yourself that it is, let's say, from 0. My R is ranging from 0. That means you are going to confirm the series that it is an alternating series. R ranging from 0, don't forget that. So that means I'll be having minus 1 raised to power 0, right? 0 minus 1 all over 3 raised to power minus 1, right? Plus minus 1 raised to power 1 minus 1 all over 3 raised to power 1, right? Plus minus 1 raised to power, R is now 2. 2 minus 1 all over 3 raised to power 2 up to minus 1 raised to power 3 minus 1 all over 3 raised to power 3 to infinity, right? So then, if I start doing the analysis, I'll be having minus 1 raised to power 0 minus 1 minus 1 all over 3 raised to power minus 1 is 1 over 3. But let's write it this way first. Plus minus 1 raised to power 1 minus 1, that is what? 0. All over 3 raised to power 1, that is 3. Plus minus 1 raised to power 2 minus 1, that is 1. All over 3 raised to power 2. Let's still write it as 3 raised to power 2. Plus minus 1 raised to power 3 raised to 3 minus 1, 2. All over 3 raised to power 3 to infinity. So then this is gonna be minus 1 raised to power minus 1 means 1 over minus 1. That is minus 1 divided by 3 raised to power minus 1 is simply 1 over 3. So minus 1 divided by 1 over 3 is the same as minus 1 times 3 over 1. So therefore, the first term is minus 3 plus minus 1 raised to power 0 is 1 because anything raised to power 0 gives us 1 all over 3. So I have the first term to be minus 3 plus this is 1 over 3. Then the next one is minus 1 raised to power 1. That is the same as minus 1, right? All over 3 squared, that is 9. Plus minus 1 raised to power 2, that is minus 1 times minus 1. That is your calculator gives you 1. All over 3 raised to power 3, that's 27 to infinity. Now I'm having plus times minus 1, that's minus 1 over 9 plus 1 over 27 plus to infinity. Now what did you observe? That the first one is minus, the second one is plus, the third one is minus, the next one is plus. If we calculated this, it would also be minus and plus minus. Now we've been able to confirm that this series alternates between negative and positive. So anywhere you see minus 1 raised to power something, just know that that series is not a positive series solely. It is an alternating series. So you will be having plus, minus, plus, minus. So please, any question? You might not be asked to test or to expand it this way, but the most important thing is to know that it is an alternating series. Please, any question first? Just show us your reaction if you did understand it, if you got it right. Welcome, my bro. Okay, then we're going to proceed with some other subtopic now, and that is absolute convergence. So what do I mean when I mention absolute convergence? There are values. We call them ordinary values. This is x. This is ordinary x. If x is equal to plus or minus 2, that is the square root of 4. Square root of 4 could be plus 2. It could be minus 2. The absolute value of x means I can never have any negative value for x. That is going to be plus 2. In essence, what I'm saying is if this value is 2, minus 2, then the absolute value of minus 2 is 2. That means I'll write this thing, modulus of minus 2. That is what we mean by absolute value. Absolute value, bar before and bar after, is equal to 2. So if I have, this is x, minus x. So absolute value of minus x is going to be what? X. Absolute value means you removing negative sign. All possible form of negative sign, removing it. Please, is that clear? Whenever I say negative or absolute value. In statistics, there is something we call mean deviation. In mean deviation, the formula for mean deviation is summation x minus x bar all over summation f of x, or summation f times x minus f x bar all over summation x. This is the formula for mean deviation. So if your x minus x bar is like this, don't forget that there is this modulus. So 3 minus, your mean is 6. 3 minus 6 plus 2, you know what summation means, right? Plus 2 minus 6 plus 1 minus 6. What do you have? You are supposed to be having 3 minus 6. Your calculator gives you what? Minus 3. 2 minus 6, your calculator gives you minus 4. 1 minus 6, your calculator gives you minus 5. But these two bars that are here, they are not useless. They are doing one work. The work is to eliminate all form of negativity. That means it is going to change from minus 3 to 3 plus minus 4, 4, minus 5, 5. Now I can remove the bars. That is what I mean by absolute value. The absolute value of minus 10 is 10. Absolute value does not carry negativity. It doesn't harbor any form of negativity. No negative sign. Is that clear, please? That is what I mean by absolute value of something. And then we can proceed to what we mean by absolute convergence. When I say something is absolutely convergent, what do I mean? This is a limit AR. If the limit is convergent, this is my condition for absolute convergence. If this is a limit AR, if this is a limit, we'll change it. If this is a limit AR, and the limit is convergent, and I calculate the absolute value of that limit again, absolute value of that limit, and that one too is what? Convergent. That means the ordinary form of that limit is convergent. The absolute form is convergent. That means I can say that the limit is absolutely convergent. Please, I'm assuring you that you will encounter this question in your exam. That means the limit is absolutely convergent. If AR is convergent and A modulus AR, absolute value of AR, is also convergent, that means the limit is absolutely convergent. But if my ordinary AR is convergent and modulus of AR is not convergent, that is, it is divergent, that means the series AR is conditionally convergent. Please, that is my talk on that. It is conditionally convergent. That means because the it is not convergent absolutely, because the absolute value is not convergent, and the ordinary value is convergent. So we just say it is conditionally convergent. The type of convergence we are seeing in that is conditional convergence, or conditioned. Its ordinary value to be convergent, then we can say that it is absolutely convergent. Is that clear? Is the condition gotten? That is a theorem, please. I want to know with your reactions, everyone, please. 1, 2, 3. I'm waiting for you guys. If you did not get it, let me know, please. Roll. Don't be shy, please. Ask if you did not get anything. Well, I'll take it as you've gotten it well. That being the case, we can look at some examples and test for absolute convergence. We've just tested for ordinary convergence now. What if something is absolutely convergent? How do we know? This is my series, -1 raised to the power of r all over r. I think it's okay this way. I hope we don't encounter something very hard. As r ranges from 1 to infinity, or do I use from 0 to infinity? Just 1 is okay. So this is my series. I want to test for the convergence of this series. Now, the formula I'm going to use to test for absolute convergence is the Allenby ratio test. That means, the Allenby ratio test says that limit of r to infinity for ar plus 1 all over ar equals to k. When k is less than 1, it is convergent. When k is greater than 1, it is divergent. When k is equal to 1, it is inconclusive. Now, for absolute tests, I'm just going to do like this. Limit r to infinity for the modulus of r plus 1 all over ar. The modulus of those values. The modulus of those values is equal to k. If k is less than 1. So please, these things, you might not be asked to use them to calculate an exam, but they will just come out this way. Please make sure to even rewatch the videos. I'm providing you with the supplement that you need actually. So it may just come out this way, and you'll be like, just answer the question. You might not need to solve anything in most cases. They might not ask you to solve anything. So k is less than 1, k greater than 1, and k equal to 1. What do we need? We just need to know that this is here. This modulus sign. Modulus sign means if this is negative, then this will definitely be possible. No way. It must be possible. That being the case, we're going to say that we've been able to establish absolute convergence, condition convergence. So divergence can also be like that, right? If the ordinary series is divergent and the absolute form is also divergent, then we say it is absolutely divergent. But if the ordinary series is divergent and the absolute form is not divergent, then we say it is conditionally divergent. That is that about convergence of series. That is that about absolute convergence, alternating series, and all that. I would have loved to explain product of series, but I'm sorry, it's going to see all this my calendar. To explain product of series, I'm going to use everything on this page to solve one question, and it's going to be an issue for many people because I'm going to be explaining and explaining and explaining with just very few people understanding it. So product of series can be so demanding actually and so hectic. So if maybe privately you can let me explain that to you. If you think you can problems too long that even the people are feeling they are feeling very tired because of the long processes. So using 10 minutes to solve a question, no big deal. No, it's an issue. But I wish you guys the best about that. That being the case, we've been able to achieve what we mean by series, basically. Series, just watch the videos. Then you can know that we've established series. Now we can go to the iterative methods for solving iterative methods for solving integrals. So we have integrals, right? Thank God, even if we didn't do very much, or if you didn't have much idea about integration, we've told ourselves one or two things about it, right? We said there is a definite integral and there is an indefinite integral. What do I mean by a definite integral? A definite integral is simply like this: an integral that is having a boundary. It is starting from something and ending at something. Let's say starting from A and ending at B, and it is integrate f of x dx. This is a definite integral. It is a bounded integral. It is a bounded. This is a non-bounded integral. B is not having any boundary. F of x dx. This is not having any boundary, but this A to B and no boundary here. How can we solve something like this? This is my integral x squared dx with the boundary from 1 to 2. And this is ordinary x squared dx without boundary. What is the difference between the both of them? This one now is going to be having a value, an exact value, a specific value. Integrate x raised to power 2. I don't know if you people still remember how to integrate. It's going to be x raised to power 2 plus 1, that is 3, all over 2 plus 1, that is 3. So this is the way to integrate this function. I've just integrated it. But because of 2 and 1 that is here, it's going to be like this. 2, 1. Now to finish it, I will now do 2, because it is between 1 and 2, right? So 2 raised to power 3 over 3 minus 1 raised to power 3 over 3. Look at what I'm doing. I first used x as 2 and I subtracted x as 1 from it. So this is now 2 raised to power 3, 8 over 3 minus 1 raised to power 3, 1 over 3. So this is 7 all over 3. If this function x squared is integrated in the bound 1 to 2, now it is being integrated without any bound. So it's going to be x raised to power 3 over 3 plus c. There will be a constant c. You can see there is no numerical value. Now, everything we want to be doing is encountering some crazy problems and using numerical values and getting the numerical values between a particular boundary. Some crazy problems that might not be easy to be solvable using the normal integral forms, integral formulas, integration by parts, integration by algebraic substitution, integration by trigonometric functions, integration by partial fractions. If those ones, integration by part, all those ones, if they are not easy, then there are ways to solve integration problems. So those ways are what we are going to be using, and they will all be indefinite integrals. So we have them as Simpson's method. I think we have so many of them actually, and I can do so many of them. But tonight, I'm just going to be mentioning those that are in the material. Simpson's method. We have the trapezoid rule. I don't know if they call it the trapezium rule in the book. Please help me check it. So Simpson's rule, trapezium rule. Those are the two rules they are using in the book. So I will have so many rules to use actually. But these are the two rules they are using in the material. And these are the two rules I'll be using for you guys. Just trust me, things are going to go well. I don't know, maybe the material is going to be kind of hard because somebody is telling me it's hard for him or her to understand. But I'm going to show you a simple way to solve these problems without stressing yourself. The only thing I will want you to know from the material is the method it comes, like the formula they are using. Just be familiar with the formula. In case they ask that which one of them is using this formula, just be familiar with the formula. Just tell them. You might not even be using it. Just tell them that this is the formula. So the trapezium method is nothing hard. I'm going to show you how simple it is. Having some calls from important people this time to chai. I think I'm gonna call him later. Guys, let's proceed. What do I mean by the integral method now? The trapezium method. Please, so to create erase confusion. To avoid, can you imagine? Let me check. Are they calling it trapezium rule or trapezoid rule? We can call it either of the two names actually, but I don't want to cause confusion with my own lecture here. Which one of them are they calling it in the material? Please, someone should help me out. Go, did you help me check the material, please? Mass 281. Is it trapezium rule they wrote there or trapezoid rule?
It's trapezium.
Trapezium. Thank you, Mr. Wilson. Okay, so trapezium rule. Lani Benjamin. Trapezium rule. Huge. So we'll be using the trapezium rule to solve problems now. This is an integral. I don't know how perfect my integral is going to be, but I'm going to form it with my brain. That let's say I have an integral like 1 over 5 sine 3 theta d theta between 3 and 2. Mercy. Okay, then this is the integral. Please, guys, if you do not understand anything, just let me know. I'm pleading. May God help every one of us, and may God crown our efforts. Just let me know if you do not get anything, please. That is why we are here. If you do not get it and you're not telling me, that means I'm working in vain, and that means you are wasting your time as well. And this time is more than important to every one of us. We all know that. So I'm going to be using the trapezium rule to solve. Okay, Miss Joy. Mrs. Joy.
Okay, please. The question, the example you solved before now, is it related to trapezium rule? You are using that one to explain trapezium rule, Abi?
Share this thing. This is normal integration. Integration.
Okay.
This is how we integrate originally. But in all these methods that you are seeing here, they are called the numerical method of integration. We have them so many. Simpson's rule, trapezium rule is there. I have Newton-Raphson method. I have Cauchy's method as well. We have so many rules that can be used instead of this normal integration method. So those rules are the ones we are going to talk about now. That means we will not be integrating using this method at all. We will not be integrating using normal integration methods at all. We'll just be integrating numerically. We call them numerical integration or iterative methods. Iterative methods of integration. Thank you. So this is my integration. My pleasure. So this is my integral, rather. I'm going to be integrating this. But what is the formula for you to always use? Just remember one thing, that the formula for what? The formula for the trapezium, the area of the trapezium, because integral is area. I don't know. I've explained all these things when I first explained integration then. I won't go back there. So integration simply means area of a region. So if this is my trapezium, the formula for the area of a trapezium is 1 over 2 the height times A plus B. Finish. So that means my integral, I, using the trapezium method, also is going to be 1 over 2 times the boundary. Give my examples so you understand them very well. Times the terms, the first term and the last term, having something in between them. So I think I'll prefer myself getting the textbook too. So to know the examples I'll have. Let me check out. I have the textbook here actually that talks about those methods. Just a minute, please. Let me find it out. I am trying to avoid, can you imagine? And I'd form a question that is not feasible. And it's going to be a waste of time for us all. Sorry, let me look for you. Okay, a minute, guys. I've asked someone to go and bring the textbook. Numerical integration. Integration. Next can integration. máa sùn èyí ló wà lẹ́yìn tọ́pìkì. Èèyàn ṣe ń sanwó ní kíkan mo ń náwó gidi ó sẹ́mi náà kọ́ ní orí ìsinsìn àti ṣe kíláàsì kan. Orí náà ṣé òun náà kọ́ ní ilé ìlú ọ̀yọ́ ilé ìlú ṣé òun kọ́ lè. Sorry about that, my people. I just asked him to go and get the textbook. I'm trying to avoid career mathematics. So sorry about that. One more instance. Application to kinematics that way. Oh my God, I'm not talking about this. Sorry about that, guys, everyone. I'm so sorry. I don't have the now material outside. Those things are just for my brain. I'm using my head to do them. But now I want to avoid career emergent system. Okay, yes. Using the trapezium rule. I have a question here that we're going to be solving. The question says, using the trapezium rule. So, yeah, I'm asked to integrate this 6x all over. Please, are we together again, everyone? Are we together now? 6x all over x squared plus 2.
Yes.
The x from -3 to +4. That is the boundary. I told you that we will not be doing anything without boundary this time around. So this is the boundary from -3 to +4. I don't know, Ms. Joy, if you could share the link with those people just now. If they could at least still learn one or two things before at least.
I'll send them link. I'll send them.
So 6x over x squared plus 2, the x. So the question says, using the trapezium rule with 8 ordinates at x equal to -3, -2, -1, 0, 1, 2, 3. Calculate, correct to 3 decimal places, the approximate value of this function. This is a function that can be solved using the trigonometric method, using and as well it can be solved using the partial integration. We can integrate this. But now they are telling us to use this trapezium rule to integrate this. What do you need? You just need to know the formula to integrate it. And the formula is like this, as I've written here before, that your whole integration, which I'm going to call I, is going to be anytime you want to use this method, use the trapezium method. 1 over 2 h. Sorry. Glory. 1 over 2 h. Open your brackets. Then the first one there, the first value there. So I'm going to call that y1 plus the last value there, which I can call, I have how many ordinates here? I have 8 ordinates. So I'm going to call that 6. So y6, I be y8 rather, 8 ordinates. So I'm going to call y8 plus 2 times, open brackets, the second ordinate. Look at what I'm doing. I'm using the last ordinate, the first ordinate plus the last ordinate, plus 2 times all other ordinates there. So that means 2 times y2 plus y3 plus y4 plus y5 plus y6 plus y7. Then once I can evaluate this, I've solved the problem. But I think the question I'm taking is too hard. I'm supposed to take something that is not even up to 8 ordinates first. Let me see if I'm going to see something less here. Okay, I'm saying 6 ordinates here. So we can solve this later after solving this one. Using the trapezoidal rule, with ordinate x equals 1.0, 1.4, we'll be using calculator here, 1.8, 2.2, 2.6, 3.0. These are the ordinates. Using the trapezium method, evaluate the integral 1 over x plus 1 dx from 1 to 3. From 1 to 3. 1 over x plus. So this is a trapezium, in case you do not know. This is what a trapezium means. The trapezium has a particular height. So this is the height, h. H is the difference between the x up and the x down. It's a pity I don't want to explain all this. I don't want to explain all these things again. So, sorry. So, we'll just go now. This is my A. That will be the last one, first one. And this is my B, which will be the last one. All others lie in between them. I really don't want to be doing that thing here again. So then, we can just take this as my H. So what is my H in this case? That my H will serve like something like a common difference. Something like what? A common difference. This is 1. The next thing is 1.4. The next thing is 1. Without stressing myself, is there anyone that can tell me the common sequence of this, common difference of this sequence?
0.4.
Very well. I wanted to say my brother has answered, but you answered as well. So 0.
Please, you can help me to move the camera closer.
Closer. What do I need to do? I just need to write the formula out again. That the integral is equal to 1 over 2 times h. There is nothing add here. The reason I'm using 1 over 2 is because of the formula for the area of the trapezium. Once it gets to the Simpson's rule, I'll just be using 1 over 3. Very simple stuffs. That's why I'm saying that it is not hard. In case you encounter problems, just solve it easily. 1 over 2 times h, open bracket, the first y. So you know this is y, right? So y1 plus 1, 2, 3, 4, 5, 6. So I'm going to be having 6. So y6. The first one and the last one added together, right? Plus 2 times all the ones that I didn't add together. That's going to be what? y2, y3 plus y4 plus y5. Now let us do this thing. How do I get my y? What does my y mean? Because these are x's. What does my y mean? So that is a simple thing as well. My y is going to be what? y1 means I'll be using the first value of x. I'll be using the first value of x. What is the first value of my x? 1.0. So y1 is going to be 1 over 1.0 plus 1, right? So y1 is going to be 1 over 1.01, right? So 1 plus 1, 2. That is 0.5. We've gotten y1 to be 0.5, everyone. What is going to be my y2? y2 means 1 over, what is the second value? 1.4, right? So that is 1.4 plus 1. So 1.4 plus 1. Calculator. 1.4 plus 1, that is 1 over 2.4. 1 over 2.4, and that's giving us 0.42. Also, y3 is going to be 1 over the third value of x, which is what? 1.8 plus 1. That is what? 1 over 1.8 plus 1. That is 2.8. And 1 divided by 2.8 is giving me 0.36. Also, y4 is going to be 1 over the fourth value, 2.2 plus 1. And that's going to be 1 over 3.2. The value is 0.31. Also, I need y5. Please, are we getting it? Are we getting it, please? I'm still going to do another example after this. 1, 2. Just 2 people are getting this thing. Okay, so y5 is going to be 1 over, what is the fifth value of x? The fifth value is 2.6, right? So 2.6 plus 1, this is 1 over 3.6. So 1 divided by 3.6 gives me 0.28. And y5 is 1 over, the next value is what? 3.0 plus 1. This is apparently 1 over 4, and that is 0.25. As the case is now, I've gotten the values of y1, y2, y3, y4, y5, and to get y6 now, that is, okay, this is y6, sorry. I've gotten the values respectively. Now I just need to apply them in the formula. The formula says that the integral I must be equal to 1 over 2 times h. What is my h? The common difference, which is 0.4. Open my bracket, y1 plus 1.6, y6. What is y1? 0.5. Plus what is y6? 0.25. That plus 2 times, so open the bracket, y2 plus y3 plus y4 plus y5. So what is y2? 0.42. Plus what is y3? 0.36. What is y4? 0.31. What is y5? 0.28. Right? So then my integral is going to be 1 divided by 2. 0.5 times 0.4. That's going to give me 0.2. Open bracket. 0.5 plus 0.25 is going to give me 0.75. Plus 2 times, open bracket, 0.42 plus 0.36 is 0.78. Plus 0.31, that is 1.01, 1.09. So 1.09 plus 0.28 is going to give me 1.37. So I have 1.37 here. So doing the math now, I'll be having 1 over 2, 0.2, open bracket, 0.75 plus 2 times 1.37 is going to give me 2.74. Am I right? 2.74, yes. So doing the mathematics here now, I'll be having 0.2 times, okay, let's just do 0.2, open bracket, 3.59,
499.
Very well. So it's 3.49 divided by or times 0.2. I'm going to use calculator for that. That's
0.698.
So that is the value of the integral, the final answer. And that is it. That is it. I assure you, by going through this video, you will definitely be able to solve any problem that involves trapezium rule. I'm telling you that, I assure you. Any problem that involves trapezium rule, you'll not be finding it hard to solve. So apparently you've been able to do many things about series, and I think successfully we were able to do series. And after that, we've been able to enter the iterative methods. And not even only that, we are able already to do the trapezium rule. So instead of doing this again, I'll just tell you to evaluate as a problem and I'm going to end the class. Evaluate the integral between the ordinates x equals to -3, -2, -1, 0, 1, 2, 3, 4. Which integral? Y equals plus 2. The x from -3 to 4. So this is the integral you should evaluate using these ordinates given to you. I wish you the best. Sometimes you might not be given ordinates. You just choose the ordinate yourself. See how I'm choosing my ordinates now. This is ordinates -3, -2, -1, 0, 1. So you can choose the ordinates 2, 3, 4, 5, 6, like that. So that being the case, I'll be awaiting your answers on this. And in the next class, we'll be doing Simpson's rule. After Simpson's rule, we'll enter Taylor series, Maclaurin series, and do some things about them. So, Ms. Joy, can you see that this trapezium rule is very simple now? In fact, Simpson's rule is simpler.
It is simple. What person don't know, pass them.
God will help us. Well, any question? More beyond. They enjoy your own Christmas. So, Happy New Year. I know so it's still the village. Wow, Mr. Benjamin. Wow. Well, everyone, may God help us all. Let's have a nice time.
Thank you so much.
It's my pleasure. So I have a class class 213 next.
All right, good night, bye.
I beg Kingsmate, you. Kingsmate.
I have that by 9 o'clock.